In this section, I'd like to discuss color profiles and color gamuts. We're going to use and refer to these concepts throughout the course, and we're going to come back and look at them again, but this is kind of our first stab at them, and they're very, very important concepts for really understanding printing. What we see here is what's called a standard color space diagram, and this large green space here, which is called the CIE color space, is the color space of human vision. And we can typically see more than we can actually capture and reproduce. And so that's really kind of our target space. It would be lovely if we could capture and reproduce everything. But as time goes on, we're capturing more and more of that color space and being able to reproduce it. The main point here are these two triangles down here, kind of the smooth triangle and then the red hard edge triangle. This red triangle represents an RGB color space, and then the kind of the smooth, more rounded one represents the CMYK color space. And this is just diagrammatically showing you how various devices have different color spaces and different gamuts. And these polygonal areas here represent the gamuts or range of reproducible colors of the various color spaces, in this case an RGB device and then a CMYK device. So it's just kind of a generic diagram to give you a sense for what gamuts are and how they fit into color space. Now, the word color space is defined by what colors we're using. In the case of an RGB device like a digital camera, a scanner, or a monitor, it's RGB colors. Then there are printing color spaces such as CMYK, cyan, magenta, yellow, and black, and then light cyan and light magenta. And we're adding more colors all the time. So when you're talking about color spaces and color gamuts and color gamut conversions, you always want to be very clear as to which color space you're in, RGB or CMYK, a capture and view space or print space, and then what kind of device that you're talking about. Now, I mentioned that every device has its own gamut, and what I'd like to do now is just switch over and just take a look at some gamut diagrams of some of the devices that we've been looking at. We're going to be talking about RGB color spaces for monitors, for instance. And here we have three diagrams. This is one for sRGB, and here again we have that CIE color space of human vision. And then here's the gamut diagram for Adobe RGB 1998, and then here's the one for ProPhoto RGB. And the triangles represents the size of the color spaces. Notice how small the sRGB color space is. Right? This is the color space for the web, and it's also the default color space for Photoshop, which is one of the reasons why I recommend when you're setting up Photoshop initially that you move your default working RGB color space from sRGB to either Adobe RGB as we see here or ProPhoto RGB. And typically my general recommendation is move it to Adobe RGB 1998. It's significantly larger, which means that you can capture and display a wider range of colors than you can in the sRGB space. The Adobe RGB 1998 in turn is not nearly as large as the ProPhoto RGB. In fact, the ProPhoto RGB color space actually includes colors that are outside of the range of human vision. And this is a color space that a lot of professional photographers and the cameras that they use work in or capture color into the ProPhoto space. I'm recommending Adobe RGB because it's significantly larger than the default color space, and nearly all intermediate and high quality cameras support this color space. So that's RGB, and you can see how there's different gamuts or range of reproducible colors for various kinds of devices. Web, general printing, and then professional photography image capture. In the same way that we're talking about, capturing and viewing devices, we can take a look at color spaces for printing devices as well. And here's two color spaces, one for a sheet-fed uncoated press, and you can rotate these diagrams to get an idea of the size and the shape of these gamut diagrams. And then here's one for an Epson 3800, which is a wide gamut, cyan, magenta, yellow, and black, light cyan, light magenta device. And notice how much larger and richer the colors are in this color space compared to the relatively small uncoated US sheet-fed coated color space. So two different kinds of printing devices, two different inks, same general color space. It's the CMYK color space specifically for the uncoated, and this is CMYK plus, or additionally light cyan and light magenta. And inkjet devices that are coming out today have even larger gamuts because in addition to cyan, magenta, yellow, and black, and light cyan and light magenta, we're starting to see additional colors such as green and purple being added to create even more and more color space that we can print to. So there's an introduction to color spaces and color gamuts. And final point here is that when we create a color profile for a specific device, such as a digital camera or a printing device, such as uncoated stock on a commercial sheet-fed press or a polar satin paper on an Epson 3800 wide gamut inkjet, we create these profiles to represent the colors that can be printed by those devices on those particular papers. And those are called paper-specific profiles. And when we go through gamut conversions from RGB to CMYK, we map the colors that are in these spaces over into these spaces here. It's called gamut mapping. And that's what we do when we print from an RGB file, such as in Photoshop, to a CMYK or a CMYK plus output device, such as an inkjet printer or a commercial printing press.